This is the video for Unit 9, Lesson 3, Special Right Triangles, 30, 60, 90 triangles.
The goal is going to be to use properties of 30, 60, 90 triangles to find side lengths. So this is actually very similar to what we did with 45, 45, 90. The only thing that's different is the ratios for the triangle. So for the 30, 60, 90 triangle, what we're going to find is that this is actually going to be half of an equilateral triangle. So an equilateral triangle is a triangle where all the sides and all the angles are the same length. So the angles are all 60, the sides are all the same length. When we cut it in half, we actually create a 30, 60, 90 triangle. So that's where these ratios are actually coming from when we take an equilateral triangle and cut it in half. So when we have a 30, 60, 90 triangle, we actually have a relationship between the hypotenuse and the two legs, in that if I take the hypotenuse and cut it in half, I actually get the shorter of the two legs that form that right triangle. So the leg that's adjacent or next to the 60-degree angle, or we could think of it the leg that's opposite the 30-degree angle, it's going to have that 2-to-1 relationship. If I was to do Pythagorean theorem to get the third side, we're actually also going to find that the leg that's the longer leg, or the leg that's next to or adjacent to the 30-degree angle, or you could think of it as opposite the 60-degree angle, is going to have a radical 3 ratio. So our ratios for this, unlike the last one where it was just k root 2, this is going to be 2k, k, and k radical 3. So a lot of different ways to remember it. One way is, the 30-degree angle. The leg next to it also has a 3. That's one way. You could remember that the longer leg is the k radical 3, and that's opposite the 60, because that's the bigger angle. Lots of ways to remember it, but our ratios we're going to use are 2k, k, and k radical 3. So the steps are exactly the same as the 45, 45, 90. We're just labeling, solving, and then substituting it in. The first two examples are using, again, the 30, 60, 90 triangle. So you might notice you can't use Pythagorean theorem. We only have one side given. They give us the 90-degree angle. They give us our, in this case, 60. So I know that this is a 30-degree angle. And so the first example is a 30, 60, 90 triangle. And then same for the next one, you can see is also a 30, 60, 90. So they only gave us two of the angles, but I can calculate that third one if I need to. So both of these problems are going to use our special right triangle relationship. So I'm going to write my 30, 60, 90. The hypotenuse is going to get a 2k, right? That's our longest side. The leg that's next to the 60, or the shorter of the two legs that's across from the 30, is going to get the k. And then the leg next to the radical 3, or next to the 30, gets to the radical 3. So you can see they both have the 3's. So the first thing we're going to do is label this out. So my hypotenuse gets the 2k. The leg next to or adjacent to the 60 or across from the 30 gets the k, and the leg next to the 30 degrees gets the k radical 3. So that's our first step, is just labeling it, and that's probably where most of the mistakes happen. So just be real careful. We're intentional how we're labeling this out, right? So we see here that they give us an 8 that pairs with a k. So I'm going to go ahead and set that up. So 8 equals k. There's nothing to really solve for here. So wherever I see a k, I'm going to put the number 8. So I have 8 times radical 3. So y is actually 8 radical 3. And then I have 2 times k, which we said was 8. And that was x. So x is equal to 16. So this one was kind of nice. We actually had the scale factor already solved for. So those would be our two answers. X is 16. Y is 8 radical 3. For the second problem, it's exactly the same thing. So we go ahead and label it out. So I have my right angle, my hypotenuse is 2K. The leg that's next to the 60-degree angle, or my shorter of my two legs, is going to be K. And then the leg that's next to the 30-degree angle is going to get K radical 3. And K radical 3 is the longer leg than K, because radical 3 is bigger than 1. So now I'm going to go ahead and set this up. I can see 12 is the side they gave us, pairs with 2K. So 2K is equal to 12. When we solve it, our scale factor is 6. And then wherever we see a 6 or a K, I'm going to put in a 6. So this would be 6. So y is equal to 6. And then 6 times radical 3 is just 6 root 3. So that would be x. So my x is 6 radical 3. And my y is equal to 6. The next couple examples are very similar. They just might have a little more solving. So again, we always start with identifying we can't use Pythagorean theorem. We only have one side. This is a 30, 60, 90 triangle. So I'm going to go ahead and use my similar right triangle to help us out. So the leg next to the 60 gets the K. The leg next to the 30 gets radical 3. And then I'm going to do the same labeling on my new problem. So my hypotenuse gets a 2K. The leg next to the 60 gets K. And the leg next to the 30 gets K radical 3. We then take our value and set it equal to the ratio. And this one's kind of nice because there's nothing to really solve for. So K is 4 radical 2. And so now wherever I see a K, I'm going to put in 4 radical 2. So I have here, if I put this in for K, y is going to be equal to 4 radical 2 times radical 3. Radical 2 times radical 3 is radical 6. And then 2 times x is 2 times 4 radical 2. So the numbers on the outside multiply. So 8 radical 2. And those would be your two answers. So in this case, we have x is 8 radical 2 and y is 4 radical 6. And those would be the two sides of this right triangle. And then I don't have to solve the third one. I already knew what it was. The next example is, again, the same type of problem, just a little bit more solving. So this is 60, 30, my hypotenuse, and I'm labeling this out. When we label our triangle here, same thing. So this is 2K, K, and this is my 30. If we pair it up, 6 radical 3 pairs up with 2K. So we're going to set them equal. And this, again, like the last one we saw, we have to get K by itself that we saw 2 problems ago. When we divide, we only divide the values out front. So 6 over 2 is 3. So my scale factor is 3 radical 3. And now wherever I see a K, I'm putting that in. So y is equal to 3 radical 3. That's that side length. And then x is, in for K, is 3 radical 3 times radical 3. That's 3 radical 9, because 3 times 3 is 9. So 9, not 6. And then square root of 9 is 3. So the length of for x is going to be 9. So your two lengths are 9 and 3 radical 3. For the last problem, Same idea. Again, we're just seeing different properties of radicals pop up, but the concept is exactly the same for all of these. So if you're feeling like it's repetitive, it's probably because it is. It's just different radical properties you're seeing pop up, like dividing, rationalizing, multiplying. So this one, again, we're going to set it up the same way. So we got our 30 with the k root 3. This one we have a whole number that's pairing with the ratio, so we might have to do a little bit of rationalizing. K is not by itself, so I have to divide by root 3. We can't leave a radical in the bottom. 6 over 2 doesn't simplify, or 6 over radical 3, so we have to rationalize it out. So we get 6 radical 3 on the top. Radical 3 times radical 3 is just a 3, so that's radical 9, which becomes a 3. And then this is 2 radical 3, so that's our scale factor. And now you would just substitute that in. So y would be 2 radical 3, and then x is 2 times 2 radical 3, which is 4 radical 3. And those would be the two lengths for the side of the triangle.
If you have any questions, you can ask in class, sign up for TEWOL time, or go to the center.